All right, what I want to do now is I want to go through a lot of the parent functions that are going to keep popping up in this class. And we're going to talk about the domain and range. So we've got our linear function, which is y equals x. And pretty much all of the linear functions are going to look similar to this, and their domain and range are going to be similar to this. Um, Now, the question that I always ask when determining domain and range is, are we allowed to have negatives? Are we allowed to have positives? And are we allowed to have zero? Now, this isn't magical. You can't just ask this question, but for the most part, this is going to help you figure out what your domain and range are in all these situations. So, for example, with y equals x, is x allowed to be negative? Well, yeah. Is it allowed to be positive? Yes. Is it allowed to be zero? Yes. So for y equals x, the domain is all real numbers. I can type. Well, what about the output? Can when you have y equals x, can y be negative? Well, sure. Positive? Yeah. Zero? Yeah. So it's also all real. Now we could get that from looking at the graph. It goes all the way left and all the way right, so it's all real. All the way down, all the way up. So the range is all real. Okay, but I'm trying to get you to the point where you don't have to look at the graph to figure out the domain and range. All right, let's look at our quadratic parent function, y equals x squared. So x, the number that we plug in, can you square a negative? Yes. Can you square a positive? Yes. Can you square zero? Yes. So the domain is all real. Now, when you square something, can it be negative? No, it can't. When you square something, can it be positive? Yes. When you square something, can it be zero? Yes. So the range is going to be all positive numbers plus zero. So that's going to be 0 to positive infinity. You see how that works? So we just said, okay, we've eliminated all the negatives. So it's 0 all the way to infinity. All right, let's try it with the cubic function. Okay, y equals x to the third. Now, the domain, can we cube a negative? Yes. Can we cube a positive? Yes. Can we cube 0? Yes. So our domain is all real. Can you cube root a negative? Can you cube a negative? Let me back up. When you cube something, can it be negative? Yes. -1 times -1 times -1 would be negative. So yes, it can be negative. Can you cube something and it become positive? Yes. Can you cube something and it becomes 0? Yes, 0 cubed. So again, our range is going to be all real. Again, you can get all of this from looking at the graph if you wanted. The domain goes all the way left, all the way right. The range goes all the way down, all the way up. Okay? And square roots. And this will, oh, not square roots, rational. Okay? The domain. So we've got y equals 1 over x. Can we do 1 divided by a negative? Yes. Can we do 1 divided by a positive? Yes. Can we do 1 divided by 0? No, you can't divide by 0. Can't do that. So only negatives and positives. So our domain, and this is a little weird, it's negative infinity to 0, but not including 0. It's the union of that and then 0 to positive infinity. So this is a fancy way of saying all of the negatives. This is a fancy way of saying all the positives. So it's the union of all of your negatives and all of your positives. Another way of saying it is all x's such that x doesn't equal 0. Okay. Range. When you divide by a number, 1 by a number, can it be negative? Yes. When you divide 1 by a number, can it be positive? Yes. When you divide 1 by a number, can it be 0? No. That's why there's this asymptote here. Okay, there's this little gap between this guy on top and this guy on bottom. When we can divide by 1 by a billion, and we will get really, really close to 0, but it will never be 0. So we're going to get the same range as our domain here, x and our negatives and our positives. Okay, but not 0. Can't be 0. All right, let's look at the square root. So square root function. Can we take the square root of a negative? Not if we're staying in the real numbers. Okay, so negatives are out. Okay, can we take a square root of a positive number? Yes. Can we take the square root of 0? Yes. So not negatives, but positives and zeros will work. So our domain goes from 0 inclusive, because it can be 0, all the way to infinity. What about the range? Okay, well, when you take a square root of something, can it be negative? No. Okay, when you take the square root of something, can it be positive? Yes. When you take the square root of something, can it be 0? Yes, the square root of 0 is 0. So we're going to wind up with the same range as we did domain. It's our positives plus 0. Okay, that's that square bracket there is telling us that it can equal 0. Okay, cube root. Okay, remember the cube root is just uncubing something. So can we cube root a negative? Yes, we can. Okay, like the cube root of -8 is -2, because negative times negative times negative is a negative. Okay, so negatives here will work. Can we cube root a positive? Yes. Can we cube root 0? Yes. So this is all real numbers, negative infinity to infinity. Can we, when you cube root something, can it be a negative? Can the result be a negative? Yes. As we said, like cube root of -8 would be -2. When you cube root something, can it be positive? Yes. When you cube root something, can it be 0? Yes. So all, and you can test all of these out. You can like take your calculator and go, okay, cube rooting this and seeing what happens. Okay. 2 more. We're going to do our exponential and our logarithmic. All right. So this is just one exponential. I need to get rid of this. There we go. So this is 2 to the x power. Well, can we take 2 to the negative power? Yes. It's kind of weird. It flips it. It makes it we get the reciprocal there. Can we do 2 to a positive power? Yes. Can we do 2 to the 0 power? Yes. Remember, to the 0 power gets us 1. So what's our domain here? All real. Okay. What about our range? Well, when we take 2 to a power, if we take 2 to a positive power, we're going to get something positive. If we take 2 to a negative power, remember, it's just the reciprocal. We'll still get a positive. If we take 2 to the 0 power, that's 1, we will only be able to get positives here. You'll notice it doesn't go down into the negatives and it never actually touches 0. It gets really, really close. So our range is only the positives. So, um, only 0 to infinity. And this time x is exclusive. We get close to 0, but we can't touch. All right, logarithms are just the inverse of that. So can we take the logarithm of a negative number? Nope, can't do it. That's not defined. You'll notice there's this big gap here. Can we take the logarithm of a positive number? Yes. Can we take the logarithm of 0? No. So we get 0 and infinity. This is not surprising. Whenever you have an inverse, you just switch the domain and range. So since logarithms are the inverse, it's just going to wind up being switched here. Well, what's the range? Can we get negatives from a logarithm? Yes, because logarithms give us the exponent, and exponents can be negative. That's fine. Can we get positives from a logarithm? Yes. Can we get 0 from a logarithm? Yes. Whenever you take a logarithm, log 1 is always going to be 0. So this is all real. And again, this is just switched from what we had before. Whenever you have an inverse, the domain and range wind up being switched. I know this was kind of long, but we're going to be dealing with these same functions all year, and you need to have this gut feel for what the domain and the range is without having to jump to a graph. You should have a pretty good idea of what these guys are.